Welcome to Managed Cloud Solutions. As a part of this entire course, we have a module called AWS Well Architected Framework. In this class, we are going to understand what is a well architected framework in Amazon Web Services. As a part of this module, we will be understanding on the below topics like the main pillars of the AWS Well Architected Framework, each framework like how to design a resilient architecture, how to design a fully highly available application with fault tolerance. Whenever you're choosing a resilient architecture, what are the different components that you need to choose, either at a compute level or even at a storage level. Whenever we develop applications, it's very important that we remove the dependencies. We'll also understand how to design decoupled mechanism for AWS architectures. We'll understand disaster recovery mechanisms. We'll also look into high performance architectures. And when we are designing a high performance architecture, we will look into selection, review, monitoring, and various trade-off areas. How to secure our application and design a secure architecture. Look into the cloud security modules like identity and access management, and how can you go ahead and secure the resources using identity access management, identity and federation. As a customer, what responsibility do I need to carry? We'll also understand about infrastructure services, container services, and abstraction services, which are a part of the shared responsibility model. And network security plays an important role in a data center world as well as in the cloud world. So we'll be understanding various network security features that are available in AWS, like how to do multi-layer networking, multi-layer architecture. We'll also look into hardware security model, how it works, various AWS security and compliance centers, how to design a cost-optimized architectures, and design principles and resources for an efficient AWS usage. Let us begin by understanding the objectives of this module. As a part of this module, or at the end of this module, we would like to ensure that we understand how to design a resilient architectures in AWS, which are fully available, highly fault tolerant. Whenever you're designing any application on AWS, how do you ensure that these applications are not dependent on each other? Ensure that whenever you're storing the data, you store the best resilient methods that are available. And the most common problem is when you have a multi-tier applications, it's very difficult for you to go ahead and configure them resiliently. And as a part of this class, we will understand those techniques. With all the resiliency, fault tolerance, it's very important that we need to also ensure the performance of our application. As a part of this module, we will also look into that and securing the applications as well as designing the cost optimized architectures for the best purpose. Let us first talk about why do we need a well architected framework. It's very important that whenever we get new technologies, for the sake of business, we just go ahead and adopt them to save the cost. It's very important that when we are implementing new tools or new set of services in our organization, due to the business requirements, we just go ahead and implement and try to provide the service to our customers. And in that busyness, we forget to optimize the used technologies. And if customers are using AWS for their infrastructure management or to run their business applications, AWS has provided a framework which will help its customers to go ahead and ensure that the services that are running on the AWS are secure, efficient, fully available, and satisfy their customer experience. An AWS well-architected framework will help the organization which is implementing AWS to ensure that the applications that are running on the AWS cloud are secure, they are performing to the most possible peak, then their applications are resilient and also with the cheapest cost. These are the four parameters that will be addressed as a part of the well-architected framework. And let us see how do we build a well-architected framework. Whenever you are considering or trying to build or trying to optimize the existing infrastructure, it is very important to consider these four factors. First is build and deploy faster. Typically what happens in a cloud environment is we try to automate as much as possible. But whenever we are trying to automate either the deployment process or the build process or the development process, we tend to leave the loose ends, and that loose ends will cause performance issues. The other parameter is risk mitigation. Typically, until and unless an organization is very strict about the organization risk, this parameter is many times ignored. Maybe they may be doing it for a data center, but when they move on to the cloud, it is very rare that people will do the risk because they don't understand the security model of the risk. This is another factor that has to be considered very well. The third factor that need to be considered is to understand the pros and cons of their architectural decisions. And this pros con analysis is very rarely done by many organizations. And as we tend to get busy into the business and start delivering applications to our customers or to the internal people, we don't tend to look at the best practices. However, it is very important that you need to look into the best practices of the cloud and try to optimize the existing cloud infrastructure based on the best practices that are evolving every day. Now, these four factors are lagging for many customers, or many of the services are being implemented without considering these four factors. AWS has created a 5-pillar well-architected framework which will very clearly talk about some of these issues that we have spoke. The first one that a well-architected framework is going to address is reliability. Now, what is a reliability? Think if a system has gone down or if a system has crashed. Now, whenever you are trying to recover, okay, after recovering a system, can you give me a guarantee that the system will work as it is or it may have an issues? Think if the system doesn't work as expected. That means your system is or your application is not resilient and reliable. And that's what we need to address. And that's what is being addressed as a part of a well-architected framework. The second point or the second pillar that we can talk is performance efficiency. We typically tend to use more number of resources. For example, my application need 4 GB of RAM. But what I do, I just go ahead and assign 8 GB of RAM. That's fine. Your application may perform very well, but it's not required to give you exactly 8 GB RAM. Maybe you could have gone with 5 GB RAM or 6 GB RAM. So we don't tend to use these resources efficiently. And we try to achieve the performance by giving more number of resources. Rather, the AWS well-architected framework performance efficiency pillar talks about giving the less resources possible with the highest performance. The other important pillar is cost optimization. I can pay $10,000 and run an application, or I can optimize it to $1,000 and run an application. Many people, without considering this, If they think that they have to pay $500 for their infrastructure, they will go ahead and pay. But they don't worry about how can I go ahead and decrease the cost from $500 to $300 or $200 and get the same performance for the application. The other pillar is security. Many people tend to look at the security from a different point of view. They think that it is the cloud provider's responsibility. Securing the data on the cloud is the cloud provider's responsibility, but it matters. If it is an infrastructure as a service, if it is a platform as a service, if it is a software as a service, based on the type of service that you take, the responsibility of the individual or the responsibility of the cloud provider will change. The fifth pillar that we need to consider is operational excellence. Now, what does that mean? It means that whenever we are running any application or a system, we need to ensure that at that moment the system is working very well. And I'm in a position to provide continuous support. Let's go ahead and understand each of them and put it into a resilient architecture. So what we'll do, we'll go ahead and put all these components, either mix and match, or either I combine reliability with performance, or I combine performance with cost efficiency, or we combine security with operational excellence. So we'll do a mix and match and understand how can these 5 pillars help me or help my infrastructure to have a resilient, high available, fault tolerant systems. Let us talk about design resilient architectures. Now, what is a resiliency? In a very simple terms, resiliency means recoverability. Now, what does that mean? Think I have a 4 GB server with 2 core processor and having maybe a 8 GB, 80 GB hard disk. Due to some application issue, or due to a kernel issue, or due to an operating system issue, that EC2 instance has gone down. And now I'm trying to recover the EC2 instance. Once I recover the EC2 instance, okay, after the EC2 instance recovery, am I in a position to go ahead and use that EC2 instance for the production purpose or not? Think, yes, I can go ahead and use it. But what happens after a few days if it is giving an issue? Maybe I thought, okay, it will work well. The moment I started, again it has gone down. So this is what we talk about resiliency. Whenever you're building an application on AWS, it's very, very important that you look into these factors. It is very beneficial if you go with AWS managed services, because if you take AWS managed services as the way or as a strategy for your resilient infrastructure, it actually brings more advantage with a less cost. As we progress, we will understand how can we use AWS managed services to achieve high resiliency. The other important component is how can I go ahead and build a highly available or fault tolerant applications. Let us first talk about what is high availability means. At any point of time, my system should not go down. At any point of time, my system should not go down. Now, how can I ensure that at any point of time my system will not go down? As we know, in AWS, we have something like multiple availability zones, and their group of availability zones are combined into a region. Now, it is our responsibility that whenever we develop an application, you develop your application or system which can be distributed geographically in a different regions. Maybe for example, if I'm in India, I should be in a position to develop my application to have one copy of my system running in India, the other copy in Singapore, the other copy in United States, or the other copy in Tokyo, or the other copy in Sydney, or the other copy in somewhere else in the world. Apart from that, you should also ensure that the availability zone failure is also taken care. what happens if an entire availability zone goes down? So whenever we design any application or system, try to ensure that we use 2 or more availability zones. Now, if you use 3 and 4, that's well and good. But if you are worried about the cost, try to go with minimum 2 availability zones so that in case of any data center fails, you have your systems up and running. As I always say, it is always better to use managed services compared to unmanaged services. For example, if I take an EC2 instance and install an RDS database on top of it, it's my responsibility to ensure that EC2 instance is updated with patches as well as the database which is sitting on top of the EC2 instance is managed. Unlike managed services where you get support to upgrade the underlying RDS, and we no need to worry, the cloud service provider will go ahead and ensure that the underlying EC2 instance as well as the RDS instance is updated. The best examples for them is to look into RDS and DynamoDB managed services. But what? Can I go ahead and consider other features of AWS? Yes, you can go ahead and consider other features like EC2 instance, EBS, Elastic Load Balancer, Simple Storage Service, Simple Queuing Service, Amazon RDS and DynamoDB. You can use any of these services and build high availability in AWS. Let us talk about fault tolerant. How can I go ahead and ensure that my application, if it goes down, it recovers and works in the same state without a complete failure? Maybe let us understand in this way. For example, I have 4 components in an application or 4 components in a system. Think component 1, component 2, component 3 and component 4. All the 4 components are dependent on each other. Now what if component 2 goes down? The moment component 2 goes down, my component 1, component 3 and component 4 may start or stop working. So how can I go ahead and ensure that the moment the component 2 is recovered, okay, my entire application starts working? Is a major factor in considering fault tolerance. So in AWS, if I have to bring fault tolerance into my applications or systems, there are some services. Let's look at those services. One is Amazon Machine Image, Elastic Block Storage, Auto Scaling, Elastic Load Balancer, Simple Storage Service, and Simple Queuing Service. If you are using these services, as you know, cloud doesn't have an upfront financial investment. So you are going to save a lot of cost with fault tolerance. We are talking about high availability and fault tolerance. How about resilient architectures? As I was telling you, AWS is located throughout the world. Pretty much you have many regions across the world by which you can ensure that your application is highly available. In case of any fault happens, the moment a recovery happens, you have systems that can take care of the load. Distributing the applications across different geographical locations, using multiple availability zones so that you can increase the fault tolerance. Ensure that in case some failure happens, you have another system as a high availability has to be considered. And it is very important that we understand how resources handles the failure. We spoke about AMI, Amazon Machine Image. If you can use AMI with launch templates, it's very beneficial that whenever you want to create systems dynamically, your launch template and launch configuration can help you to produce the exact image so that at any point of time you can go ahead and automatically scale. As you scale, you can increase the high availability and fault tolerance. Now, either I can scale an application and achieve high availability and fault tolerance either using a dynamic configuration or static configuration. In case if it is a static configuration, you can run scripts, bake into the AMI and get it done. Or what? If it is a dynamic configuration, you can just go ahead and use API invocation or run some scripts or run some command line tools or through AWS management console, you can achieve it. Once you have the AMI ready, okay, at any point of time, in case if one of the system is failed, you can quickly replace it with a new instance or the healthy instance. That is the benefit if you are using AMI. The second one that we can talk about is ELB, Elastic Load Balancer. The beauty with the Elastic Load Balancer is when you have multiple healthy instances behind the load balancer, okay, it is the responsibility of the Elastic Load Balancer to identify the healthy instance or unhealthy instance and pass the traffic. The benefit here is Elastic Load Balancer has its own host name, which you can map it with your concerned DNS and then start balancing the traffic. Typically, your Elastic Load Balancer can identify unhealthy instances and it can also terminate the unhealthy instance. And then it can also produce or it can also trigger healthy instances. That's a benefit of Elastic Load Balancer. Now, the other important component is auto scaling. How can I go ahead and build a resilient infrastructure? The other component is auto scaling. It can actually help you to automatically scale instances based on some traffic. For example, if you think that my capacity of a load balancer or the average load that I can handle is 1 million requests, the moment you see that my systems are actually crossing more than 1 million requests, you can automatically scale. And this scaling will increase the capacity so that you can better address the user requests. You can actually auto scale systems either in horizontally or vertically. When I say horizontally, you have a 4 gigs of RAM that can be increased to 6 gigs, 8 gigs, or you can automatically scale your applications horizontally by increasing the number of instances. Typically, whenever you use web servers, you will be using a horizontal scaling. What till now we were talking about auto scaling, AMI. What if I have a database? Let us talk about it. When you have an RDS instances, how can I go ahead and ensure high availability and fault tolerance? Typically what we do is we go ahead and create a standby instances. Any RDS instance when you go ahead and take a standby instances. One active instance, the other standby instances are typically taken care. Apart from that, just to ensure that I am in a position to recover the data, we also take a backup of the data. So that backup can be a point in time recovery backup, which can help you to recover the data. Either you can take a snapshot of your database explicitly, which can ensure that automatic AZ failover is taken care. We can also ensure that the instance components failure or service health disruptions in any availability zone is taken care. Storage is a very important component in any infrastructure management service. Either you take it as a cloud or even a data center. Now let us go ahead and understand in AWS, how can we go ahead and choose appropriate services, appropriate AWS storage services. But before we understand, why do we need a resilient storage? Let's talk about why do we need it. It is very important that whenever you're running big data kind of applications or whenever you're taking backup, restoring or recovering the data, for a disaster recovery, or trying to manage a data warehouse, or archiving the data for a long term. It is very important that we need to have a resilient storage. Let us see those options that are available in AWS. Elastic Block Storage, Simple Storage Service, Amazon Storage Gateway, Snowball, Amazon Glacier, and Elastic File System. These are few important storage services that are available in AWS, which can help you to build resilient storage system. Let us talk about one important factor of EBS. Elastic Block Storage Resiliency. As we know that every EC2 instance by default comes with a root volume, and we typically don't use root volume to store our data. However, we go ahead and add extra EBS volumes. And the beauty here is you can actually take a snapshot of EBS volume and store it in a different availability zone for a backup, so that in case of one availability zone goes down and the EBS goes for a toss, you have a snapshot which can actually be used back. In case of an EC2 instance failure, you can go ahead and detach a EBS volume and directly attach it to a new instance. This makes EBS highly reliable, and backup of these volumes can be created either in a different availability zones, and you can move from a different availability zone to a different region. In case if you would like to take EBS snapshot, either you can use API, AWS Management Console, or AWS Backup to ensure high durability, and these EBS snapshots or the volume snapshots can be stored in Amazon S3 for a long-term purpose. EBS snapshots can be used to create either a new EBS volumes, or you can create an exact replica of the existing volume when the snapshot was taken based on the point in time. So this is how EBS will help you to build a resilient architecture. Now, the other important service that we have to talk about is EFS, Amazon Elastic File System. Typically, we use EFS to go ahead and have a file system which can be shared across multiple systems or multiple EC2 instances. EFS typically helps you to share the data, and the most commonly used EFS is a Linux based workload. For example, when you want to share a data between multiple hosts and multiple Linux systems has to talk or use a common storage, we use EFS. But however, Amazon also provides EFS services for your Windows. This makes it more preferable service to share the files in the network. The beauty with EFS is you can store the data across multiple availability zones, which will actually give you high availability and also durability of the data. You can easily access the files either across regions, across VPCs, across different AWS accounts. That makes EFS a resilient feature for you to bring in your AWS architecture. The other important service in AWS is Amazon S3. As you know, Amazon S3 is redundant across multiple geographic locations. In case of a data center failure, you can still replicate an entire AWS S3 bucket onto a different region itself. And the benefit with S3 is it has a versioning feature. So once you enable the versioning on S3 bucket, okay, at any point of time, you can go back and recover accidental deletions. As I was telling you, S3 can be used either as a cross-region replication, or you can use it in the same region replication. Apart from that, S3 also offers multi-storage classes. This will actually help you to reduce the cost in case if you would like to store your data for long time, or even for short time, high availability, or for fault tolerant features. What else I can use to make my storage resilient? One is S3, which can actually give you 99.99 availability. The other one is having a multi-AZ RDS with multiple masters, or you can have a master and replica, read replica. You can use DynamoDB, which is schemaless for high availability. You can use elastic block storage with EC2 instance, or you can use Glacier to archive the data for long-term retention. For the last many years, we have seen that most of the time whenever we build an application or systems, they are pretty much dependent on each other. And that's going to cause a lot of problems in the upcoming application designs or architectures in the cloud. It's very important that we go ahead and follow a decoupling strategy. Now, what is this decoupling strategy? As a part of the decoupling strategy, you will go ahead and isolate the multiple components of your application or system and ensure that one component is not dependent on the other component. Try to make as small as the decoupling or as loose as possible in your application, so that you will, even though you may have more components, it's okay to manage more components independently rather than dependency. This was the same problem we have been facing for the last many years. Many years we have seen that if I have an application, if I have a very big application, even if I do a small change, I need to redeploy the entire application, reconfigure the entire application. That's a very huge time-taking process. And there are many advantages that you can get if you decouple your application services or application components. One is for sure high availability. And you can also have either synchronous communication or asynchronous communication based on the type of application. It will also help you to manage and archive your data separately based on the type of application. It will also help you to increase the throughput of the service, easy feature management, and it will also help you to customize your application based on the type of programming language, based on the component, based on the system requirements. And AWS will actually support you with some of the services to build a decoupled architecture. Some of the important services, if you want an asynchronous communication, is SQS, SNS, and Kinesis. But what if I want a synchronous communication? You can use classic load balancer, application load balancer, and auto scaling features. Let us go ahead and understand about synchronous communication. Now, in a synchronous communication, okay, we ensure that both the sender and receiver are highly available and they are communicating with each other in real time. A typical synchronous decoupling can be achieved with a application load balancer or even a classic load balancer. If you can observe in the diagram, okay, I have two sets of instances. One is a web server instance, the other one is an application server. Now, typically what we do, we combine application server and web server into the same instance. But here, what we have done is, we have separated application server and we have separated a web server. And then we have placed a classic load balancer before the web server, and in between the web server and an application server, you have an application load balancer. Now this is in single availability zone. The same has been replicated into a different availability zone to ensure that my application is highly available, fault tolerant, and resilient. But what if I have an asynchronous system? Yes, AWS also helps you to decouple the applications asynchronously. One important component is SQS. Let us take the same example. We have two sets of instances, web servers as well as workers. In this case, A worker will pick up a job from a web server and does the job. Now, whenever I pick up a job cannot have it's okay if a job doesn't happen in real time. So whenever you don't want any real time communication between the decoupled systems or decoupled applications or decoupled components, you can use something like SQS. And SQS can help you to retain the message for a time so that this message can stay in the queue. You can fetch the message, process it at your own sweet time, and then tell to the application that you have completed the processing. That's why in between the communication and the web servers, in between the people who are communicating and the web servers, we have a load balancer, that's your ELB. But in between your web servers and workers, we have an SQS queue, which is actually maintaining the request queue as well as the response queue. Let us now understand how do we design a multi-tier architectural solution with these techniques. Typically in a multi-tier architecture, we commonly have database as a separate layer, web as a separate layer, and the business logic will be a separate layer. So we typically call web layer as a presentation layer, the logic layer or the business logic where the business logic is executed will be typically an application, and where the data is stored is always a database. In a presentation layer, we typically have mobile pages or mobile app UI. Typically we use Angular, React, nowadays PHP, ASPX in the previous days. Typically a logic layer will have the functionality or behavior of an application, and the database is always stores the data. Now let us understand disaster recovery in AWS. There are two important factors that you need to consider when you are doing a DR planning in AWS. One is the recovery time objective. The other important concept is recovery point objective. Now what is a recovery time objective? For example, there is a disaster that happened, and the time that you took to restore a business process to a level such that it can work is your recovery time objective. And what is a recovery point objective? Suppose the disaster happened. Now, within how much time, within how much acceptable time you are in a position to lose. For example, if a disaster happened and if I lose 1 hour of data, I'm fine. That's your recovery point objective. Now, whenever you are implementing DR, ensure that these two things are analyzed and accordingly the decisions are taken. There are some best practices that you need to follow when implementing an AWS DR. First one is test. Perform as frequently as possible your DR tests. Execute your DR plans. Conduct mock tests. Very important. The second one is putting an alerting mechanism, either using CloudWatch or SNS. Third is backup. As much as possible, take regular backups so that in case something happens, you can switch to a DR environment. The other one is user access. Try to see that all the ways I can give my user the secure access. In case of a DR also, I should be in a position to give secure access to my users or even customers if required. The fifth factor is automate. Wherever possible, try to automate your DR tasks either using CloudFormation or using AWS OpsWorks, or even required use Beanstalk. Let us talk about how to design a high performance architectures. Performance efficiency is a concept that has to be considered when designing your applications. So typically a performance efficiency depends upon 4 different areas or factors. The first one is right selection. If I cannot select right workload architecture or right workload schema, okay, then we are going to face problems. Sometimes I may have to choose API gateway based on the situation to have high performance, or sometimes I have to take an EC2 instance and expose an API. The right choice based on your application will bring better efficiency. And we know that many times when we implement a service, maybe 5 years back or 8 years back or maybe 2 years back, we know that the technology improves on a day-to-day basis. We have seen many architectures that if I have implemented an application maybe 6 years before on an AWS cloud, you are still stuck with the same 6 years old application. You're not reinventing the technology with the application. What happens is it's always better try to use new technologies as they emerge. And it's a very important factor to monitor the performance of your application system. Now, whenever you do performance of an application, either before an upgrade or after an upgrade, you need to go ahead and keep monitoring the application so that you know how it is performing. The other factor is, or the other fourth area to focus on is trade-offs. Finally, try to see new technologies like caching, compression, sharding is improved so that your user has better usability and performance. If you implement all of them well, but if your user is not feeling that, then there is no point in implementing it. Maybe your infrastructure is working well, but the user experience will not be attained. One selection component is compute resources. Okay, based on my application, based on the usage, based on the number of resources, okay, maybe different patterns of application management, maybe different configuration type. Either you choose a virtual machine, containers, or serverless. Maybe if you want, if you want something like, choose a virtual machine or a EC2 instance, you can simply take a Amazon Light Sale, which is secure and resizable compute capacity. Or no, I don't want to make my application to deploy on a virtual machine and take some time to go ahead and start the server. Maybe I want to make it very light. Okay, go ahead and use containers like ECS. If you use ECS, it's highly secure, reliable, okay, and you can easily scale you and run your containers and store those images in an ECR. Try to manage access. In case if required, you can go ahead and take it from ECR and deploy it on an ECS. Or if you want, you can go ahead and use fully managed Kubernetes cluster. That's your EKS. No, I don't want to use containers. I want to be more efficient. I want to break down my application into very small pieces. What we can do is we can go ahead and implement serverless with AWS Lambda and API gateway, which can actually give you a better throughput for a cheaper cost and can only run whenever required or whenever needed. So these are the things that you need to consider when you are choosing compute resources. But what? The next one is storage. What factors do you need to consider when you are choosing storage? If it is a block type of data, okay, then just go ahead and store or use elastic block storage. Maybe based on the type. For example, my operating system has to access, then EBS is better. If my application has to access via a URL, then simple storage service is better. Maybe when multiple EC2 instances want to access the same set of data or a folder, then EFS is better. Or you want to just store for a long term, Glacier is better. Based on the type of access, based on the frequency of access, maybe you want to access every 6 years, okay, go ahead and use Glacier. But if you want to use frequent access, that too, and a process has to access, then go with EBS. But someone has to download a file frequently, okay, go ahead and use simple storage service. Based on the availability, durability, throughput, you can make a decision. So the other important factor is database selection. very, very important. Many times, many engineers or many implementations gets failed because they don't choose the right database. It's always better to use managed databases. Either you use a managed RDS so that it can handle structured and unstructured data, or use Aurora, which is more powerful than MySQL, which can give you compatibility and give higher performance. Or if your data is not structured, go ahead and use DynamoDB, where you can go ahead and upload the key value data store with unstructured data. But what if you want an in-memory database so that you can improve the performance of the application, or run a in-memory application? Then go ahead and use Elastic Cache. But what if I want to go ahead and run data analytics? Do I have anything? Yeah, we have something like Redshift, where you can actually maintain an entire relational database warehouse, and which can be used for analysis and reporting. No, I want to use next generation databases like quantum enabled as well as blockchain enabled. Okay, we can go ahead and use Amazon Quantum Ledger database. It actually provides you transaction log for all the changes in your application. Or maybe if I want to use something like Keyspace databases for Cassandra, Apache Cassandra, you can go ahead and use it. Or maybe I would like to store geospatial information, satellite information, or DNA information, genome information. We can go ahead and use Neptune. The graph-based databases. Compared to relational database or non-relational database, these are graph-based databases, which can store millions of data relationships and their appropriate connections with a millisecond latency. These are from a database point of view. But what if I have to choose it from a network point of view? Let us understand them. It is very, very important that whenever you design a network, there is a less latency, high throughput, and no physical challenges, no expansion challenges. In case if I want to go ahead and build something of that sort, what does AWS offer me? You can use methods like EC2 placement group, VPC endpoints, AWS Route 53 latency routing, AWS direct access, EC2 enhanced networking, EBS optimized instances, Amazon S3 transfer acceleration, and can I use Amazon CloudFront. This can actually improve the network performance of your infrastructure as well as your application. Oh, all of them have implemented, but without a continuous monitoring and review, it's going to be waste. So on a day-to-day basis, you need to go ahead and review the performance of your application and systems and see how they are working. Now, performance review can include defining the code in the form of infrastructure as a code, or trying to use DevOps CI/CD pipeline, set up metrics and monitoring, which can go ahead and give you alerts on a timely basis, conduct performance testing, make metrics, calculate the metrics, do a comparison, or go ahead and do a graphical analysis, visualizations, put it and see where you're performing well and where you're not performing well. For that, you need a continuous monitoring. Before the end product is delivered, it is very important that the product monitoring has to be started. We can use alarm features of AWS to go ahead and see if something got breached, a threshold got breached. You can actually put an alarm to trigger actions. You can go ahead and do monitoring using AWS CloudWatch and can trigger services like Kinesis, Simple SQS, or even a Lambda function. There are other trade-offs that you can actually go ahead and implement, like trade consistency, durability, space, time, or latency, or you can even calculate that how can I deliver the high performance. Some of the trade-offs include, or some intelligent ideas that you can implement is, how can I go ahead and add only read replicas so that I can scale heavy workloads? How can I go ahead and use caching solutions such as Amazon Elastic Cache? How can I go ahead and partition or use sharding techniques? Or I can use CloudFront or Snowball to improve the performance. That's a lot? No. Let us see how can we go ahead and secure our applications and build a secure architecture. Whenever you are considering cloud security, these are few factors that you have to by default consider. One is identity and access management and how do we implement it. The other component is shared responsibility model. Third component is network security layer, and fourth component is on how to secure our own data. Let us first talk about implementing an identity access management service. Typically, whenever you log in to AWS account, you log in as a root user, or whenever you create a user, you will get a root account. So by default, we suggest you not to use the root account. However, create a sub account or create an IAM user account and assign the administrative privileges to that account and go ahead and block or disable the access to the root account or enable multi-factor authentication for all the users. And we typically create different groups like admin group, developer group, test group, and we can go ahead and give permissions. Maybe an admin group like Bob and John will have full permissions. Developer group like Martin, Jeff and Kumar will have less permissions. Or testing groups such as D'Souza and Ben will only have access to the testing systems. Let us go ahead and understand how IAM will protect your resources. IAM has various options like policy control access. You can integrate this IAM with either your existing LDAP or having the Active Directory. You can also go ahead and use IAM to sign your APIs either using certificates or secret keys. The beauty of IAM is that you can actually go ahead and maintain unique credentials like access keys, login, passwords, and multi-factor authentication. It is also important to identify the federation services. Now, why do we actually use identity federation? Many times when we are working in enterprises, we may have an existing authentication system which could have been configured and we are running for a long time. And now we are trying to adopt to the cloud. I don't want to go ahead and bring a different identity access management system for my cloud. Rather, I would like to use the existing identities. Either maybe in my data center or maybe I can create a new identity source and then integrate the identities or federate the identities from one identity management system to the other identity management system. Maybe for example, I have an Active Directory and I want to federate the identities from Active Directory into my Cognito and integrate my Cognito with the other applications so that whenever a user logs in, he will get that single sign-on experience. Now, whenever I'm integrating or federating the identity, I can use technologies like SAML, which can help you to exchange the identities. Or maybe I can use third-party identity providers like Google, Facebook, which uses technologies like OAuth. This is how you will be able to identify and management federation can be done for a single sign-on access or to integrate the data center infrastructure with the cloud. Let us talk about AWS shared responsibility model. Security is a shared responsibility between AWS as well as the customer who is using it. Whenever we say, we have to always differentiate between security of the cloud and security in the cloud. AWS is responsible for security of the cloud and the customer is responsible for security in the cloud. Now, what does that mean? For example, AWS is responsible to ensure the infrastructure is secured, which includes hardware, software, networking, physical facilities. However, the customer is responsible to customer is responsible to manage the security and the usage of services. For example, if there is a misconfiguration of a role, AWS will never take the responsibility. It is me who has configured the role wrongly. So typically, if you have to understand the security and shared responsibility model, it is typically categorized into three sections or three areas. One is infrastructure, container, and abstract services. Let us go ahead and understand each of them. In infrastructure shared responsibility model, typically the services that comes are EC2, Amazon EBS, auto scaling, and VPC. If you observe the diagram very clearly, AWS typically manages, the underlying compute, storage, database, networking, AWS specific IAM, edge locations, availability zones, regions, and AWS endpoints. However, it is the responsibility of the customer to go ahead and do client-side data encryption, data integrity authentication, server-side encryption in case if it is a file system that is being used, network traffic protection like encrypting the traffic, integrity of the network traffic, and identity of the network traffic is managed, operating system security like EC2 instance security. If you have misconfigured network and firewall configuration, that's customer responsibility. What you have deployed an EC2 instance on a and you have installed an application and that application is performing badly, then it is the responsibility of the customer, and the data itself is also should be managed by the customer in infrastructure services. This is a shared responsibility model which has to be understood by pretty much everyone in the organization to ensure the security of the systems is taken care. In container services security model, for example, managed services like RDS, EMR, and Elastic Beanstalk, where AWS will take care of platform and application management, operating system and network configuration. However, client-side encryption, data integrity authentication, network traffic protection like encryption, integrity, identity management, as well as customer data, which includes customer IAM, firewall configuration, should be managed by us as an AWS customer. Then the third type of service that we need to consider is abstracted service, where as a customer, I only need to take care of client-side encryption, data integrity authentication, and only data. Remaining everything like server-side encryption, network traffic protection, platform, application management, operating system, and the underlying hardware, physical resources, everything is taken care by Amazon. Being an architect and being a security guy, you should always see wherever possible, go ahead and start using abstracted services. Wherever possible, as much as possible, go ahead and use abstracted services. This way, as a customer, I can decrease the burden, and as I decrease the burden, increase the efficiency, reliability, as well as I'll be having a cost savings. Oh, this all is good. But how about network security aspects? What kind of network security aspects we have in AWS? Let us go ahead and understand how can we go ahead and build a network security layer in AWS. You have different options that you need to consider when designing a well-architected framework. One is network access control list, security groups, operating system firewall, then file system encryption, or you can encrypt the swap. Now let us go ahead and understand one by one. First, let us talk about operating system firewall. Typically, any EC2 instance, will have two security controls. The outer layer security control is your security group, by which you can go ahead and allow the traffic to come inside the operating system. That's your EC2 instance. But the moment the traffic reaches the EC2 instance, Okay, now whether to process that traffic or not is dependent upon the operating system firewall. So this way you can have a dual layer security at the operating system, at the entry of the operating system or after entering into the operating system, OS firewall as well as Amazon security group. Now I can go ahead and place typically EC2 instances in a network. Now do we have any network level controls? Yes. Typically we put our EC2 instances in a subnet. Now at a subnet level you can have network access control lists, which can help you to filter the traffic, either inbound traffic or even outbound traffic. Now let us go ahead and see a sample network architecture where we go ahead and have front-end web servers, application servers and database servers. Now all of them are protected. For example, front-end web servers, I can have a first layer of defense as an elastic load balancer. Then you have Amazon EC2 instances. Then you have another Amazon EC2 instances and a set of other EC2 instances. Now this diagram doesn't have any security layer, but let's go ahead and improvise this with a network security options. So the first load balancer itself is protected with a security group. Then all your application servers can be protected by another security group, and the RDS will also be protected by a security group. This way you can go ahead and ensure that at each layer there is a security group, and you can put a filter telling that only EC2 security group or front-end web servers can only access application servers, and only application servers can access web servers. You can go ahead and draw a clear demarcation of which security group can access other security groups. With this, you can go ahead and ensure that only you are allowed to access the front-end web servers, and you are not being given access in case if you access to application servers or database servers, they will be denied. So this is how you will go ahead and implement a multi-layer architecture with network security options. The other important factor that need to consider is storing the secrets, and it's very important to manage AWS secrets, and the best security solution that we have to manage our secrets is HSM, Hardware Security Module. It's a feature provided by AWS. So the entire life cycle of a secret, like keys or like any algorithms or any important data, can be protected, which are using cryptography. Any cryptographic keys can be protected by a hardware security module. Now using a HSM, you can actually control how you create your cryptographic keys, how you manage your keys, and how you dispose or archive your keys. We typically use AWS HSM in database encryption, digital rights management, public infrastructure authentication and authorization, document signing, and transaction processing. The other important security feature of AWS is AWS Web Application Firewall and AWS Shield. AWS Web Application Firewall will protect you from common web exploits. So you can go ahead and write rules that will allow what kind of traffic has to be passed, and you can also block and monitor the web request, and you can define conditions. This WAF will help you to protect against the web attacks, and it will help you to manage the rules and saves the time by pre-configuring or by the existing pre-configured rules. WAF will also help you to get the better visibility into the traffic, and it also offers you real-time metrics and sample web requests that got generated in case if there is any discrepancy. The other important feature that AWS provides is AWS Shield. In case if you would like to protect your resources from distributed denial of service attack, then you can have AWS Shield service. There are two types of shields. One is Shield Standard, Shield Advanced. So Shield Standard is free, which is provided to all customers of AWS. It can do network as well as transport layer DDoS protection. It can automatically mitigate the DDoS attacks. However, Shield has less features. If you want extra features, like you want to protect your EC2 instances, you want to protect your ELB, you want to specially protect your CloudFront and Route 53, then you can go ahead and enable AWS Shield Advanced. It also provides you real-time visibility into attacks. It can be integrated with WAF and Web Application Firewall. The beauty with AWS Shield is you will get 24/7 DDoS response team so that you can manage and mitigate your application layer DDoS attacks. The benefits of using AWS Shield are it can be seamlessly integrated with other AWS services. There are no routing charges. You can customize your protection based on the resource. It is very cost efficient compared to many other products, and you can scale at any level, and it scales as per your application and the traffic. You can also build an automatic network flow which can have inline management of DDoS and attack visibility with a good visualization and data insights. The other important factor that you should always consider is to save the data or to secure the data. Let us go ahead and see what are the different options that we have in AWS to secure our own data. So typically we store our data in S3. Now S3 has an access control mechanism where you can go ahead and put access control, telling that who should have read access, who should have write access, who should have full access control, either at an object level or at a bucket level. And pretty much every object is served using SSL. So by default, the application that is accessing your S3 data is by default encrypted. So you have a server-side encryption for every request that comes to an S3 bucket. In case if you want, you can go ahead and have a client-side encryption also before it is sent to S3. You can also ensure that accidental deletion of data can be protected using multi-factor authentication and by enabling the bucket versioning. And S3 is designed in such a way that each and every request that has come to S3, either to access the data or to access the bucket, is very detailedly logged. In case if you want to be incompliant, or if you have to ensure that you need to take care of some compliances of your organization, AWS has many components. That is, AWS can ensure that they have a compliance center which will ensure you and which will provide you different white papers on risk compliance. It can also provide you security bulletins. It can also provide you custom penetration testing or customer penetration testing activities. They will also provide you best practices, and AWS can help you to build better IAM and multi-factor authentication strategies. Oh, all this is good, but don't you think there is a lot of heavy cost on this? Now let us go ahead and understand how can I go ahead and design a cost optimized architectures. Now what is a cost optimization? Cost optimization is continuously ensuring and refining the systems so that you are less charged. Now, do we have any provision in AWS? Yes, AWS has a cost optimization system which will actually help you to effectively manage and provide the best services at the lowest cost possible. Now, okay, how can I go ahead and implement it? First thing is you need to consider cost at a design level. So what aspects that you need to consider at a design level to ensure that you get the best cost optimization possible or ever available? First, adopt a consumption model. Now what does that mean? Try to see wherever possible you only pay for what you use. kind of services. If you are running 2 minutes a service, just try to see which service fits into that model. That whenever you run 2 minutes, you are only charged for 2 minutes. Try to see you measure the overall efficiency from a business point of view, that and the entire cost associated with those systems. Try stop spending money on the data center operations. Try to focus on your customer and business projects rather than looking into the IT infrastructure. Try to analyze and attribute each and every expenditure. Calculate the usage, cost, map it with the return on investment, and take a decision. Wherever possible, try to use managed services which will reduce the cost of ownership, like RDS, SQS, ELB, which can also help you to scale and provide you a cost-effective service. How can I go ahead and manage a cost-effective resources? Appropriate provisioning, ensuring you give right sizes to your resources. Select the services based on the geographic location. Try to purchase those instances like on-demand instances, spot instances, reserved instances, so that you can save cost on EC2 instances, or try to choose managed services. Do any of this, you will have a cost saving. So what or how I can actually appropriately provision to reduce the cost? Try to use APIs, SDKs with cloud monitoring so that you can automate the adjustment and resource utilization. Do not use excess resources and capacity workload beyond the requirement. Use trusted advisor wherever possible. When you have high density users groups and managed instances, try to go ahead and use small DB on a single RDS instance for testing purpose. Migrate the instances or try to use snapshot of a demand instances and delete it, or possible go ahead and use Lambda so that whenever you run, you use it. The other important factor is doing the right sizing. It's a very important factor. Try to revisit your EC2 instances at least every 6 months. Notice that workload changes and appropriate instances has to handle the workload properly. Try to build or use trusted advisor hints that are provided by AWS. Use spot instances in the auto scaling groups and try to combine and manage your high availability and cost effectiveness. Will actually help you to provide better. The other important thing is optimizing the EC2 instances. Try to optimize the spot instances, EC2 fleets, or use on-demand instances or reserved instances. Use any of these purchasing options so that you can save time as well as cost. The other important consideration that you can go ahead and do is try to use those services in which your customers are there. For example, if my customers are from India, I'll go ahead and use those services and regions which are very near to India. Or if I have a data center in India, I'll go ahead and use it. Think if I'm currently in Paris, it's better to use Paris data center so that my geographic location will bring me advantage, will have a reduced network latency. Okay, I can have multiple instances at multiple geographic locations based on the right location, right people. Try to use monthly calculator to model solution in different geographic locations. If you have less businesses, don't try to go ahead and put more servers there. Try to use CloudFront and Cloud Deploy or Code Deploy so that you can actually provision proof of concept environments in different regions based on your customers. And the other important factor is try to use managed services. Wherever possible, try to use managed services like S3 Bucket, Elastic Cache, Lambda, RDS, DynamoDB, so that this can actually, like if you use RDS and DynamoDB, it can help you to decrease the developer cost, DB administrator cost, and the time you will be saving. So The other important factor that you need to consider, or how do I ensure that my knowledge is enlightened? You can go ahead and refer white papers. Typically, there are hundreds and hundreds of white papers that are available from AWS with all the best practices. So what I would suggest you all to go through these links and then refer to the white papers and ensure you get good knowledge so that you can optimize your resources. Thank you, and looking forward to see you in the other videos.